Hello guys, and welcome back to another episode of chemistry. All right, and of course today we are going to continue our study of organic chemistry. We're going to be looking at the concept of hybridization in this class. Hybridization. All right, so please do not forget to like this video. All right, if you have not done that now, please pause the video and click on that like button now. All right, do not forget to subscribe to this channel. Of course, subscribing will send notification to your phone whenever we publish a new video. And don't forget to keep sharing this video so that others can also learn. Also, this tutorial is brought to you by the O3 School JAMB app. I'm going to talk about the app soon, but let us see a question from the app. This is a 2023 question number 12. 2023 question number 12. It says, in methane CH4, carbon undergoes hybridization to form dash hybrid orbitals. Carbon undergoes hybridization to form dash hybrid orbitals. A, SP, B, SP2, C, SP3, D, SP3D. All right, so please, I'm going to come back to that question and many more questions because a lot of questions are being set on hybridization every year. So you do not need to joke about it at all. All right, so please also do not forget to download the application from Play Store. The application has all you need to succeed in your exam, has all the past questions for your exams. All right, has also the classroom feature with lecture notes structured according to the JAMB syllabus. All right, a lot of you don't know that you need JAMB syllabus to succeed in your exam. All right, so if you have that app, you have nothing to worry about JAMB syllabus because the lecture notes there, the notes on the app are structured according to the JAMB syllabus to just make you focus on the areas you need to focus on. Then of course we have the question start feature where you can start for question according to topics. Then we have the UTME mock challenge every Saturday. You participate with your thousands of other JAMBites, win amazing prizes, get used to JAMB pass and likely exam questions. And what's more is that you see your result released every Saturday, so it helps you to track your progress and build confidence towards the main exam. All right, if your hands are not too busy, go to Play Store, download the app immediately and activate for a small fee. Pay the sacrifice, do not be stingy to yourself. Now let's look at what hybridization. So we say hybridization, let me put that down, the definition. Hybridization is the mixing of atomic orbitals to form hybrid orbitals of equal energies. All right, so simple as ABC. So we say hybridization is a mixture of atomic orbitals, all right, to form what? Hybrid orbitals of what? Equal what? Energy. Okay, let me explain this in simple terms so that you'll be able to understand. Okay, for example, if you mix salt and water, salt plus water, are going to have what? A mixture of what? Water and salt, right? If you mix sugar and water, are going to have what? A mixture of what? Of sugar and water. Okay, the same thing happens when it comes to what? Orbitals. We can mix what? Orbitals together, and once we mix orbitals together, we're going to have what now? Hybrid what? Orbitals. So if you mix, let's say s orbital plus p orbital, okay, we're going to have what? This is the shape of what? S orbital, which is O. In the next class, we're going to look at shape of orbitals. All right, this is what? O. Okay, it's spherical what? In shape. I say O, sorry, I mean spherical. This is shape of what? S orbital is what? Spherical. Then now this is the shape of what? Of p orbital, which is dumbbell. Okay, so you can mix what? These two orbitals together to now form what we call what? A hybrid what? Orbitals. Okay, this is what the p orbital, this is what the s orbital. So you can now form what? Hybrid orbitals. Okay, this one that is formed, this mixture that's supposed to be formed here now is called what? The hybrid what? Orbital. Hybrid orbital. All right, so it's as simple as ABC. So that is what hybridization, the mixing of what? Of atomic orbitals to form hybrid orbitals of what? Of equal what? Energy. All right, and there are what? Three types of what? Orbitals. Sorry, there are three types of what? Hybridization observed, okay, in carbon in organic chemistry. All right, three types of what? Of hybridization for carbon in organic chemistry. So I'm going to look at three of them. Number one is what? Is SP3 hybridization. Number two is SP2 hybridization. Then number three is what? Is SP what? Hybridization. Okay, so to make it easier for you, just understand that what? SP3 hybridization is the hybridization between what? One s orbital plus what? 3p what? Orbitals. Okay, so you are mixing what? One s orbital with what? 3p orbitals. Okay, so that means in the ratio it is being mixed is what? This is 25% of s orbital, and then is what? 75% what? p orbital. Okay, now in sp2 hybridization, we're missing what? One s orbital plus what? 2p what? Orbitals. Okay, this is what? 33%, and this was 67 what? Percent. Okay, and then of course in sp hybridization we're going to be missing what? One s orbital plus what? One p orbital. That was what? 50-50. Let's share it with no good. Okay, so that is that for that. So in sp3 hybridization, we're missing what? One s orbital and 3p orbitals. Let us talk about the sp3 hybridization to start with. It will be our major focus for today. Okay, so sp3 what? Hybridization, like we said, is the mixing of what? One s orbital and 3p orbital. So sp3 what? Hybridization. Sorry for my ugly handwriting. So I'm going to have what now? S, which is what? sp3, rather, which is what? S plus p plus what? P plus p. Okay, in the ratio what? 25% S and what? 75% of what? Of p. Okay, now carbon is the sixth what? Element, okay, in the periodic table. That means it has what? 6 electrons in its what? In its atoms or shares. All right, so this is what? Carbon. The electronic configuration of carbon is what? 1s2, 2s2, 2p what? 2. Okay, this is the electronic configuration of carbon. Now, if I'm going to use the electron bus diagram, then that means the ground state electronic configuration of carbon can be drawn like this. All right, so I'm going to have your first bus, which is the 1s orbital, having what? 2 electrons with what? Opposite spins. Then your 2s orbital, which is higher up, having what? 2 electrons. Your 2s orbital having 2 electrons also with opposite spin. Then this is 2s. Then what? For 2p, okay, we're going to have what? No, 2p has what? 3 degenerates. Okay, so we have what? px, py, and what? pz. px, py, and pz. If you have not watched electronic configuration, you are doing yourself. But please go to our video on electronic configuration, watch it, and come back here so that what? You become very easy for you. Some of you will be skipping lessons. You watch 1 minute and skip. You are doing yourself, not us. All right, so please go and what? And watch that video. Okay, so we're saying that p orbital has what? 3 degenerate. Okay, it is presented like this. This is for the x, the s. All right, this is p, y. Okay, and then this is what? pz. Okay, you now have pz this way like this. Okay, in the z what? Having the z orientation. Okay, like this. All right, so that is what the p what? Orbital. It has what? 3 degenerates, px, py, and pz. P orbital has what? Has what? A shape of what? It has a dumbbell shape. You say it has a dumbbell shape. Okay, so in the next episode, we are going to look at all those ones, shape of what? Of orbitals. All right, so now the point is that what? P has 3 degenerates, so 2 electrons are in the p orbital here. So I'm going to have 1 electron following Hund's rule of maximum multiplicity. I don't know why I'm obviously talking about electronic configuration here. Okay, so if I'm using Hund's rule of maximum multiplicity, we say that what? Fill in electrons into orbitals singly before electron pairing can take place. So this is the first electron in the 2p, then this is the second electron in the what? In the 2p. Okay, so this is the what? Ground state electronic configuration of carbon. Ground state what? Electronic configuration of carbon. All right, now we also have the excited state electronic configuration of carbon. In the excited state electronic configuration of carbon, 1 electron from what? From the 2s orbital is promoted to the what? To the 2p what? Orbital. Okay, so now I'm not going to have what? Let's see the excited state electronic configuration. So I'm going to first of all have what? Your 2s having, sorry, your 1s having your 2 electrons. This is 1s, and I'm going to have what? Your 2s like this. All right, now having 2 electrons, no, having 1 now because it's been promoted, having 1 electron, then have what? Your 2p. Okay, having what? 3 degenerate, your first electron, your second electron, then what? The what? 1 that has been promoted. Okay, so now this is what happens. Okay, now in hybridization, what happens is now that this 2s orbital, this 1 electron in what? In the 2s orbital. Okay, this is 2s, this is 2p. This electron here, this 2s orbital will what? Will now mix. This 2s orbital will now mix with this what? This 2p what orbital. Okay, so that we'll now have something like this in the hybridized what state, and I'm going to have our what? Our 1s. Okay. Okay. Then we'll now have what? Our hybrid orbital having what now? 4 what? Electrons. Okay. 1, 2, 3. That's like this now. The first one, the second one, the third one, and then this 2s orbital that is now mixing with this what? P orbital. So you now have what? 1 again. Okay, so this one is now what? The hybrid orbital. Okay, so this is what happens in what? In what? In SP3 what? Hybridization. Okay, so the 2s orbital mixes with what? The P mixes with what? With all what? With all of what? Of the orbitals of what? Of the 2p, okay, orbital, right? It's mixing with all this px, mixing with the py, and mixes with the pz. Okay, so you have to what? Take note of that. So that is what the hybridized or state, okay, for SP3 what? Hybridization. Okay, so now each of what? This is the first SP3 orbital, this is the first SP3 orbital, then this one is the second SP3 orbital, this one is the third SP3 orbital, this one is the fourth SP3 orbital, all of them having what? 1 electron what? Each. Okay, and first an example of what? Of a compound that what? Exhibits what? SP3 hybridization is what? Is methane. Okay, CH4, methane. Okay, CH4, that's what methane. It's an example. Take note, very important. Okay, if the question wants to come out from the exam, okay, something like this kind of question is what they will ask you. Okay, an example of a compound that will exhibit what? SP3 hybridization is what? Is methane. All right, you know this is methane. Having what? 4 hydrogen atom or bonded what to it. Okay, so this is what? SP3 what? Hybridization. Okay, so now this example of a compound that exhibits SP3 hybridization, like I said, and also the shape. Okay, in SP3 hybridization, the shape of the carbon atom is what? Is tetrahedral. Tetrahedral. Take note of that. Okay, the shape of what? Of the carbon atom is what? Is tetrahedral, and the bond angle, okay, is what? 109.5 degrees. Okay, please take note of that. Okay, in SP3 hybridization, the shape of carbon is what? Of carbon atom is what? Is tetrahedral, and what? The bond angle is what? 109.5 degree. You must take note of that. All right, you must take note of that. And of course, also there's also, because what? There's always what? Only one hybrid orbital. There's only one hybrid orbital in what? In SP3 what? Hybridization. Okay, we have one hybrid orbital. Okay, having of SP3, 4 SP3 what? Orbitals. Okay, now that is that for that. Now, because what? It has what? One hybrid orbital, it forms what? One single bond called what? The sigma bond. It forms one bond called what? The sigma bond. It forms what? One bond called the sigma bond. Sigma bond is what? Represented what? Like this. Okay, that is what? Symbol for what? For sigma or bond. Okay, so it has what? One hybrid orbital. Now note that what? Hybrid orbitals what? Leads to the formation of what? Of sigma bond. While unhybrid orbitals leads to the formation of what? Of pi bonds. We talk about it more when we talk about what? The SP2 hybridization. So let me quickly go to the SP2 hybridization. If you do not understand anything about this, please make sure when you drop a comment. All right, and of course I will attend to it. Okay, so now let's look at what? SP2 hybridization. And in SP2 already we know that what is between what? Is formed between what? SP2, 1s orbital and what? 2p what? Orbital, in the ratio what? 33% and what? And 67 what? Percent. Okay, so simple as ABC. So the same thing happens. We have the ground state electronic configuration of carbon. Then we now have what? The excited state. So let us just go straight to the excited state. So in the excited state, okay, of carbon, I'm going to have, there is electron bulk diagram straight up. Okay, so I'm going to have what? 2 electrons here. Then here, I'm going to have what now? 1 electron. Then here, it has already been promoted now, all right? So I'm going to have what? 1 here, 1 year, 1 year. What happens in SP2 what? Hybridization is that what? Is that this 2s orbital, okay, mixes with what? Only what? The px and what? And the py what? Of what? Of this what? of this what p orbital. It mixes only with what? With the px. This is px now. This is py. This is pz. Okay. It does not what mix with what with this pz orbital. All right. It only mixes with what with this what px and the py orbital in sp2 what hybridization. Okay. So that we're now going to have something like this. We're going to have what something like this. This one is what is 1s2. In the hybridized state now, I'm going to have what 1s2 here. This is 1s2. Then we now have what 2p. We now have this 2s and what this p mixing together, and now have what something like this. 3 now. 1, 1, 1. These 2s are suddenly mixed with what with this 2px and this 2py. Okay, so that now we now have what pz what at the top here. Okay, simple as ABC. Now this pz what has more energy than what than this what other what orbitals. It has higher energy than these orbitals. Okay, but that is not what the major what concern here. The major concern here is that what the 2s orbital does not what mix with what does not mix with it. Okay, so now this is what happens in what in sp2 hybridization. This is what happens in sp2 what hybridization. Simple as ABC. Okay, so yeah, we now have this one that is from here. This one at the top here is called on hybrid orbital. On hybrid what orbital. This one is called on hybrid orbital. Why this one is what is the what is the hybrid what orbital. Okay, and of course I remember stating in the what in the last class that what that hybrid orbitals leads to the formation of what of sigma bonds. Take note. Why I say on hybrid, on is this thing on the board? On hybrid orbitals leads to the formation of what? Of pi bonds. Of pi. You know your pi now, your pi symbol. Of pi bonds. Okay? Okay, you can say what? Sigma bond or what? Pi. Okay? Pi bond or sigma bond. Alright? So hybrid orbitals lead to the formation of sigma bond. On hybrid orbitals leads to the formation of what? Of pi bond. Okay? So take note of that. So since we have what? One hybrid orbital, we have what also have what one what on hybrid orbital, then of course we're not going to, that means that what that sp2 hybridization has what one sigma bond and has what one what pi bond. Okay, an example of a compound that what there is a bit what sp2 hybridization is what is ethene. ETHENE, that's what C2H4. Okay, it's an example of what of a compound that what that exhibits what sp2 hybridization. All right, and the shape in sp2 hybridization, the shape of carbon is what is trigonal planar. It's trigonal. All right, please take note of that. Trigonal or planar, and the bond angle is 120 degrees. Okay, you must take note of that. The shape of what of carbon in what in sp2 hybridization is what is trigonal, and what the bond angle is what 120 degree. Okay, so usually what this one is already present in what in carbon to carbon what double bonds. Okay, this sp2 hybridization usually is present in what carbon to carbon double bond. sp3 is present in what carbon to carbon what carbon to carbon single bond. All right, single bond. Why what of course sp will be present in what carbon to carbon what triple what bond. All right, let us go to what sp2 what hybridization. So that sp now I done what sp2 and look at what sp hybridization. Okay, simple. The example under sp2 here is what 18. Okay, we talked about that. All right, so C2H4. Now let's talk about the next one, which is what sp hybridization. Okay, so now what happens in sp hybridization also is simple. Similar thing happens. Okay, so let us use the excited state of what of carbon. Okay, I'm going to have what our 1s here with what 2 electrons. We are going to have what our 2s with 1 electron. We are going to have what our 2p. Okay, with 3 what 1, 2, 3. Okay, this is what 1s, this is 2s, this is 2p. All right, likewise in sp hybridization, all right, the 2s orbital only mixes with what with the px orbital of what of the 2p orbital. So I was going to have what px is px, py is what pz. Okay, so now in what in sp2 in sp hybridization rather, the 2s orbital mixes with what only what this px orbital. Okay, so now why it does not mix with what this py and what this 2pz and this what pz rather, it does not mix with this py and this pz. It only mixes with what this what px. Okay, so we're now going to have something like this now. 2. They are now going to have something like this. All right. So you are going to have what? 1 electron. You are going to have what? 1 electron. Okay, so that will now have what? Py, 1 electron, Pz, 1 electron. That's what Py, Pz. It has nothing to do with this Py and this Pz. Okay, it only misses with 12 with Px. Okay, so now, now we'll now have how many unhybrid orbitals? We'll have what? 2 what? Unhybrid what? Orbitals. Okay, and then here have what? Hybrid what? Orbital. Here, this one is the hybrid orbital. You get it now? Okay, so this is what happens in what? In sp hybridization. Okay, so the 2s orbital only what? Missing with what? Only what? Px what? Degenerates. Okay, of what? Of the p what? Orbital. Okay, so it does not miss with what? With py and the pz. So we now have 2 unhybrid orbitals. We have what? 1 hybrid orbital. So because it has 1 hybrid orbital, that means there's what? 1 sigma bond in what? In what do they call it? In sp what? Hybridization. Okay, and then there's what? How many unhybrid orbitals are here? 2 are unhybrid orbitals. That's what? Py and pz. So I'm going to have what? 2 pi bonds. Okay, 1 sigma bond and what? And 2 what? Pi what? Bonds. Okay, in sp hybridization. So you must what? Take note of what? Of that. And of course, the shape of carbon in what? In sp hybridization is what? Is linear. It's linear. Take note of that. Bond angle is 180 degrees. Please take note of that. Okay, the shape of what? Of carbon in what? In sp hybridization is linear, and the bond angle is 180 degrees. Okay, so now having known all this now, we have talked about what? Carbon to carbon. I talked about carbon to carbon single bond. Carbon to carbon single bond. Carbon to carbon single bond. You say it has what? How many pi bonds? Does it have pi bond? No. Okay, that is this one is present in what? SP3 what? Hybridization. Okay, so carbon to carbon or single bond is present in what? SP3 hybridization is present in carbon to carbon single bond. Okay, this one has what? SP3 what? Hybridization. Okay, and how many sigma bond? Just one sigma bond. Okay, then has say carbon to carbon double bond. That's what? SP2 what? Hybridized. Okay, it has 1 sigma bond and 1 pi bond. Okay, while carbon to carbon triple bond has, that's what? sp hybridization has what? 1 sigma bond and what? And 2 pi bonds. Okay, so now take note of what? Of all this. Okay, carbon to carbon single bond has what? Is what? sp3 hybridized. Carbon to carbon double bond is what? sp2 hybridized. Carbon to carbon triple bond is sp hybridized. Okay, so now we say what? sp3 has 1 sigma bond, sp2 1 sigma bond and what? 1 pi bond, sp 1 sigma bond and 2 pi bond. Now note that what? Sigma bonds are stronger, okay, than what? Than pi bonds. Okay, they are stronger. They are stronger than what? Than pi bonds. Okay, but of course this alkane, the triple bonds in what? In alkynes rather. This is an alkyne. Okay, in alkynes. This is what? This is an alkane. This is what? An alkene. Okay, so now the triple bond in alkynes are stronger than the single bond in what? In alkanes. Okay, now it's difficult. It's easier to what? To break a single bond than to break what? 3 bonds. Okay, together. Imagine breaking 1 pencil and breaking 3 pencils together. Which one will be stronger? Okay, of course, breaking 3 pencil will be more difficult than breaking what? A single pencil. Okay, so because of that, we said that what? The triple bonds in alkynes, they are stronger than what? Than single bonds. Okay, in alkanes. Okay, but the sigma bond is what? Is stronger than what? Stronger than pi bond. You must take note of that. All right, so you must take note of that. So now, having known all this, we're going to go to the O3 Schools JAMB application and answer some questions to cement our knowledge on the topic hybridization. Okay, let us go. 2023, number 12. They say in methane, CH4, carbon undergoes hybridization to form dash hybrid what? Orbitals. Okay, in what? In methane, that was CH4. In methane, carbon what? Undergoes what? Hybridization to form what? Dash hybrid orbitals. So I already said that what? In alkanes, that's what? Carbon to carbon what? Single bonds. Okay, there's a bit what? SP3 what? Hybridization. Okay, so now they form what? In the excited state of carbon using the electron Bohr diagram. There's something I want to bring out. This is it. Okay, then we now have what? Okay, so 1, 1, 1, 1. This is the hybrid orbital. Okay, this orbital that is formed is called what? Degenerate what orbital? Degenerate orbital. Okay, degenerate orbital means what? They all have what? Equal energy. Equal energy. Equal energy. All right, so I just want to bring what that point out. Okay, this one that I call what? Degenerate what orbitals. Degenerate orbitals what? All have what? Equal energy. Okay, so they say which of the following present hybridization in in methane CH4 carbon undergoes hybridization to form dash hybrid orbitals. That's simply what? C, option C, SP3 what? Hybridization. A SP, B SP2, C SP3, D SP3D. So let's continue. Now, they say the 2005 number 27, 2005 number 27, they say the shape of hydrocarbon compound methane, that is CH4, is what? Is not tetrahedral? Yes, we said what? The SP3 what? Hybridized what? Carbon has what? A shape of what? It has what? A tetrahedral shape. Tetrahedral what? Shape. And a bond angle of what? 109.5 degree. We said that. Okay, so you must take note of those what things. Now, A, they say square planar, B planar, C linear, D tetrahedral. Correct answer is tetrahedral, D. Then let's see 2004 number 46. 2004 number 46. They say carbon is tetravalent. It's tetravalent because A, the 2s and the 2p atomic orbitals what? Hybridize. B, all the atomic orbitals of carbon hybridize. C, the electrons in the orbitals of carbon are equivalent. Okay, D, the electrons in both the 2s and the 2p orbitals are equivalent. Okay, and the reason why they're called what? They're tetravalent because what? The 2s and the 2p atomic orbitals what? Hybridize. Okay, it's because what? The 2s and 2p they hybridize together to form what? One hybrid orbital. All right, all having equal energy. So now let us see 2001 number 48. Which of the following represent hybridization in ethyne? Okay, which is what? C2 what? H2. Okay, in ethyne, C2H2. That's what? SP what? Hybridize. That's an example. Okay, it's SP what? Hybridize. Is SP what? Hybridization. So let us see. A, they say SP2. B, SP2D. C, SP3. D, SP. Correct answer there is what? Is SP. So let us see chemistry 2022 number 12. They say the following hybridization in carbon atoms except the following hybridization in carbon atoms except A, SP3, B, SP4, C, SP2, D, SP. Okay, correct answer there is what? Is B, SP4. We'll not talk about SP4. So we say there are only 3 types of what? Hybridization of carbon. Talk about the word the SP3, talk about what? The SP2, and talk about what? The SP. All right, so this and many more questions are on the O3 School JAMB app. Download the application today and start practicing your way to success. Okay, do not forget to like the video, don't forget to subscribe, and do not forget to keep sharing. See you at the top.